Topic is benzilic acid rearrangement. In this benzil, we have to take a starting compound benzil, and this is a structure of a benzil which converts to benzilic acid. We have to convert this diketone structure to acid with the help of strong bases like sodium hydroxide, potassium hydroxide. As we know that sodium hydroxide, potassium hydroxide are strong bases which easily dissociate into K plus OH minus or Na plus and OH minus. So first step of this rearrangement is this is the structure of benzil, and as we know that this is a polar bond, though it is possible this happens that electron is pulled toward oxygen when this OH is there having negative charge. So this is a driving force, and because of this pulling of electron toward oxygen, because oxygen is more electronegative than carbon, then the thing is that this becomes like this. Everything is as it is. Now this carbon, because oxygen electron is toward oxygen, going toward oxygen, so oxygen is having negative charge, delta negative, and this is having delta positive charge, carbon. This ring, aromatic ring as it is. Now this delta positive, delta negative, and OH minus charge, so minus charge, negative charge will attack on this carbocation. So if this structure is attacked by this OH group, the next structure becomes CO C minus. Now this is oxygen and oxanium aromatic as it is, and OH. Now you see this structure. This structure is not stable structure. Negative charge is there. This oxygen cannot retain this negative charge forever, so it will again share between this carbon and oxygen. And because it is, you see here, the valency of carbon is 4 satisfied, but when this electrons will be shared and bond will be formed again, CO bond, then valency would become 5, which is very unstable, so it is needed to be broken. One bond should be broken. So the thing is that this aromatic bond, carbon aromatic bond, is broken. Why? Because when the bond is broken, the negative charge, if you see the structure, the bond is forming, so this carbon does not requiring one bond out of these 3, one be broken, and this will be broken because the electrons will be with this aromatic ring, and because of resonance structure, this aromatic ring can adjust or stabilize this negative charge. So the thing is that this bond is forming, and the group, this aromatic group is broken. And if you see this structure, as we saw in first case, same things happens. Because of negative charge, this polar bond, electron moving toward oxygen, same is the case here too. This is negative charge, so it can migrate from this carbon to this carbon, and this carbon can adjust like what it did this carbon. So next structure is this carbon, negative charge here, delta negative, and because this group, aromatic group, is attached here, this carbon, so we can draw this way. Okay, and this carbon, oxygen, double bond, you see, double bond, and OH, this OH. So group is broken from here, attached here. This is conservative step. Even though we are showing this by breaking, this doesn't happen this way. This is intramolecular rearrangement. The simultaneously this happen, the bond breaking and formation of this bond. For our understanding, we are writing like this. Now again, as happened here also, you see oxyanion form. This is first oxyanion, this is second oxyanion, and this two is unstable, and here acid is formed, COOH. Now the thing is that we know what is acid. Acid is the substance which forms H plus according to Arrhenius theory. So this bond, OH bond of acid, is very polar, it can be broken, and H plus can form. Here is O minus, so this H plus will be attacked by this OH minus, or this H plus will be attached to this O minus, delta minus. So structure will become like this, OH, C double bond O and O minus. Hydrogen is gone without electrons, so O minus. And if you see, we are using this strong bases, K plus and Na plus. If we are using KOH, there is K plus, NaOH and Na plus. So this structure what is formed is minus, and here it is Na plus or K plus. Now this is salt of this benzoic acid. This is benzoic acid salt. This is our product. This is forming. This is soluble in water, polar solvents, and we can recover very easily this benzoic acid. Simply what we have to do is that we have to make this acidic. You have to add this in acidic solution, or we have to add acid there. We have to make the mixture acidic. When it is done, then this alpha hydroxy acid is formed, and the solubility of this acid is polar solvent is less, so it can be easily precipitated out and separated. So what we are doing here is we are taking benzene, we are using strong bases. This O minus is attacking on this carbon because this is polar. The oxyanion is forming, OH is attaching, and when again the bond is shared between carbon oxygen, because it would be highly unstable to have 5 valency of carbon, so bond is breaking, and especially this aromatic group is breaking because this can stabilize negative charge electrons. And the situation here is same. This is polar, so again this C plus can form carbocation, and this will attach here. Oxyanion form. This is second oxyanion, and this is unstable structure. This H plus broken from here can attach here on the oxygen, and OH will form. This Na plus or K plus will form ionic bond. This is coming from the base we are using. When this salt is made acidic salt, then we will get alpha hydroxy acid. This is structure of benzilic acid. Now while doing this, what we have to again